Welcome back, everybody. Today, we are going to make a mini PCB that belongs to the signal conditioners group. And the mini PCB is going to be a voltage to current circuit. Current. Yeah, that one. Images. So it's going to be based on an op-amp. And where's a good example? No. Well, I'm just going to draw it for you, but just so you know, I'm not. This is the concept that we're going to be going for right here. That's the concept. Yeah. So, anyways, yeah. So that well, you know, I'm not just making this up. It's an actual circuit. So, starting at the top, let's go to mini PCBs. Let's go to the product catalog. Let's go to the signal conditioners tab. How about we make this one 10, and this will be a voltage to current. Voltage to current. And then we'll do this one current to voltage. Okay, cool. And this will be a dual op-amp. A dual op-amp, and then a bias trim pot. Yep. And I'll just put in process right now. Okay, and then if y'all can't see me, but I'm going to the cover sheet that I've got. Overview, click update, and it ripples through all my sheets and it's counting stuff. And so in process now says 7, and that's what we're working on. Okay. Engineering change order. Let's get an engineering change order going. Repos, mini PCB, engineering change order, ECO base. This is going to be 1007. We go up to ECO form. Close that. Zoom in. Okay. So this is a, we put the part number here, 08A-010. 1007. That's a cool number. Okay, and then see, now it's behaving today. Yeah, today. And DWG number at 010A. And statement of change. Initial release. Statement of risk. No known risks. Justification of change. Product development. That's how you spell development? I think so. And we'll do save and close. All right. This is in the, no, it's not in analog to do, no. I need to renumber it. 08C5. Well, that's why we built the ECO system that we did. 08 Charlie. Hey. 08 Charlie. 08 Charlie. Perfect. save and close. So no harm, no foul, right? If we go into PDFs and we look down at 1007, right? This is the first time we clicked the button. Save and close was clicked. The other ones are grayed out. This is a stamp of what computer and what user and when the button was clicked, and then the location that the PDF was saved to. And this has the 08A. That's fine. We're not going to delete that. That's a record, right? It was a button click. That's a record, right? We'll hang on to that. And we changed it to 08C. That's fine. Perfectly fine. Not breaking any rules, right? And this is information about when the button was clicked, the time this PDF was created. So, yeah. So that's the beauty of this simple ECO-based system that we made. Every PDF, every time any of the buttons are clicked, it creates a new record. And I don't have a process for deleting the records. They just accumulate. So, yeah. All right. Let's go over here. Let's say this project. Let's say copy, and let's go up to signal converters. Cancel. Let me hit signal converters. Let me come here. Say new project. 08 Charlie. All right. Now we'll come here, say copy, select folder, right click, rename, Charlie, and 5. Oh, I need to change that to 5. All right, no worries. Boom. There it is. Cool. This guy too. Nice, 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 nice. All right, save. Save and close. Boom. Finally, we're out. All right, we should be done with the ECO until we have the schematic, and we'll insert the image. But back to here. Nice. Okay. Rename Charlie and Charlie. If anybody's name is Charles, they're probably like, why is she saying my name? Well, you just have a very nice name, that's all. Charlie. Man, he's a bully. I know. I know. Tell me about it. Okay. Let's set this as the active project. And why have I been duplicating not so good descriptions of the project? I should leave a description, but let's see. The one we did yesterday was a window comparator. Nice, cool. Okay, and then this guy is going to be edit description. This is going to be a voltage to current circuit. Okay, cool. All right, nice. Now let's go and delete the stuff that doesn't belong there just because, you know, we're feeling more OCD than productive at the moment. This is in signal converters, Charlie 5. 08A. Everything 08A gets blown away. Delete. Okay. Okay, we can, I'll just close that. We'll need to open it again, but not at the moment. And let's edit the script while we're here. This is probably going to fit on a 50 by 50, so we'll just change this right here, Charlie, and here and there. Boom, those are replaced. We got our rat's nest in there from last time. Cool. Save. change the date to September 7th, 2022. Save. Close. Schematic. All right. Here we go. Okay, so this is the window comparator from the other day. And we don't need two reference voltages. We will need one to set the control voltage. Yes. Yes. And we're going to use a dual op amp. We're going to use one of the op amps as a voltage buffer. Is that what I want to do? Sure. We'll use one of the op amps as a voltage buffer. TP7. Move this guy. Oh, man. Oh, man. There we go. Out 1 click, down 3 clicks, out 2 clicks, back. Out 1 click is fine on the front. So normally, if you put the, what was it, the LF412, was that a dual? Whoops, I'm in caps mode. LF412, something like that. Then you need to add more space here, like that, or it's even longer, right? But I'm not putting the part number because I want y'all to be able to feel free to pick your own, you know? Y'all are engineering students. Y'all can figure this out. You don't have to rely on me for everything. You got this. You got this. Okay. Name, ground, cool. I don't need TP3 on ground, so I can delete that guy and move this up a little bit and like that, sure. Okay, got that guy. Now, the reason I hesitated was because I want one of the inputs to also be able to set the input voltage. And we're gonna no, I don't want to delete that. I'll use that. Okay, that's fine. All right, cool. But delete this right here and that right there. Cool. All right, now grab this, move it over here, out of the way. Like that. Okay, cool. I need to spin this op amp around. This is, in the window comparator, this was an op amp part that we were using as a comparator part because the symbol is the same and the pinout was the same, but it was a comparator. And here in this guy, it's an op amp again. So let's see. So if you like, look at the properties, op amp, dual, yada yada, op amp, yeah, okay. And then we'll take that off right there. We'll grab this, we'll move it back. We're going to drop everything lower. Yeah, that'll be okay. Something like this. Grab more of it. Move group. Something like this. Okay. Let's come over here, grab this guy, drop it here. Now we need a transistor. Been a while since we used a transistor, right? We're going to use an N-type. I'm going to use a PNP, so BJT. And what did I say? This is going to be this guy, BJT emitter base collector. Yep. Okay. Like that's good enough right there. Move the group away from the edge. Like that. Okay. One more click or back? We'll see. We'll leave it here for the moment. Okay. Give me the dot. This guy. Come here. That guy. This. To here. Escape. Move. All right. Now, for the exciting part. Delete this. Right here. No. All right. Okay. And we'll clean up this right here for a second. And, oh, this is going to be fun. We're going to have 2 trimmers on this one. Hey, I want to copy it. Copy this guy. Should I put this on the high side or the low side? We're going to put this on the higher side. And we'll rotate it like this. Sure. Clockwise, we'll take it up so it will decrease the current. It'll increase the. It'll decrease the current if it's that way. Poof, here. Now, clockwise will increase the current. That was what I. Okay, we'll rearrange this a little bit more like this. That. Okay. Let's drag this out a little bit. Yeah, this would be better. Okay, we'll put this over here. Yes, something like this. Except I can pull this guy to the other side. I can hit mirror again, like that, and then that looks fine. Then we'll drag the resistors so they line up with the transistor. Okay, cool. All right, draw this guy down to here. Boom. Draw this guy down to here. Boom. Draw this guy up to here. Boom. Draw this guy over to here. And the wiper, we want to connect down to the bottom. Hang on. Clockwise is going to take it toward 3. That would increase the resistance. Increasing the resistance, you're going to get more voltage drop for the same given current. It's going to reduce the current. So that would reduce the current. Whereas if I put it toward the top, taking it down there is going to increase the resistance, decrease the resistance. So we would get less voltage drop per current, so the current would have to go up. So yeah, sorry about that. Should have said yes. I agree. And that goes there. All right, cool. That should work. Or I could just leave 3 no connected, but we're gonna connect it. Yeah, we'll connect it. And we have 2 outputs. Let's see. So let's grab this, drag it down, move to here. That's good enough. Give me a line. Drag that line over to here. Okay, and grab this guy, drag it here, and move. And let's see. You know, it would be better than sending these to. then sending them to ground would be to send them to like here. That's the voltage here is pretty low, just 0.6 volts. So all right, well, keep moving, Nolan. We'll figure out if we want to move those caps around in a second. All right, so like there. That's good. Now there. Okay, so this is what's going on. So we got power, V plus, right there. Bam. Okay. So this op amp is going to drive this transistor to turn on. Now this op amp is trying to make the voltage at these two pins the same. So it's going to turn the transistor on, which is going to push current, sourcing it not through the op amp. This is just to control the transistor. It's going to source it through the transistor from plus V plus. Current is going to flow through here, right? I made a mistake. Hey, that doesn't connect there. This doesn't connect here either. This goes down at the bottom. Yeah, sorry. I know I'm watching this myself, and I'm going, no, well, he's going to skip ahead, Nolan, just skip ahead. He's going to catch it in a second. See, most people would edit this out, but I want you guys to see what engineering is really like. So you're just getting it raw and unedited and completely 100% honest. Is that a bug or is that a feature? Oh, both, neither. Who cares? Nobody's watching. No, people are gonna watch. Just watch. Yeah, even if it's like 80 years from now, if somebody stumbles upon it and finds it and goes, "Oh my God, well, I love circuits too. That's pretty cool." Then so what? It's 80 years ahead. That's fine. Okay, so we got this is better. Because here's what we have going on, right? Let me draw a picture for you guys. We'll put it like this. All right, cool. Okay, so we have two inputs and we have two outputs, and we have power and we have ground. And the inputs are a voltage, right? So, yeah. Anyways, I'm not going to draw this. Sorry, guys. So we have two inputs, we have two outputs. The inputs are going to be a voltage, and the outputs are going to be essentially a current loop, right? So we have a voltage signal on the input and a current signal on the output. That's why it's called a voltage to current source, like this. Signal converter, I like that. Dual comparator circuit. It's a dual op amp circuit. Op amp. Oh my God. Op amp circuit. Single supply, THD, trimmers. Today is the 7th of September. Revision A, engineering change order 1007. Revision A, title. Voltage to current. Cool. Okay. So the current is, so you're going to have a load over here, and that load is going to experience a current signal which is controlled by this voltage signal here. Yeah. It's this guy right here. Get me back on nets. Yep, cool. There it is. That's it. That's it. That's the feedback. Okay, so the op amp will take an input signal. Yep, we'll pull it off like this. Send this up, back, and back to here. Escape, grab this, move this down, and move this guy down. Move group, there to here, to back to here. Hey, gets me every time. Yeah, I want to connect that. Yep, I sure do. Here to here. So I don't know which one's worse. The old version of Eagle that made you do an extra click to connect it, or no, Altium is definitely worse. Altium goes, oh, you want to connect that, and it just connects everything. Oh my God. There's probably a setting in Altium where you can just disable that, like default connect when they come close to each other. But no, it's bad. Okay. Okay. So this trimmer right here has an output bias voltage. Bias. This is N plus. Hang on a second. We're going to do this a slightly different way. We're going to take a copy. Okay. Should I put caps up here? You know what? We're going to go ahead and, yeah, we're just going to do it. We're going to load this guy up with caps. I just, want y'all to have a good experience, and, caps like salt and pepper, just sprinkle it on. Just, hey, not that button. I hit the save like an OCD person. That's okay. That's fine. That's perfectly reasonable. Yeah. Computers crash. Programs crash. It's good to always hit save. Save. Now, this guy, most people, right? Like maybe even a year ago, I would have just connected that to ground. Been like, yep, there it is. Right, the bias voltage is to ground. This guy goes to ground. This control input voltage is with respect to ground. Right? And that's exactly what I'm going to do. I'm going to connect that to ground. Except I'm going to do something special. We're going to use this unused input as the negative input, the low side. So this would be like in plus, and this would be in minus. So a differential input. Right? See, the current doesn't flow into the op amp. It's going to flow to ground. When it flows through this resistor network, by the way, which you can trim, haha, you're welcome. When it flows through this resistor network, a voltage drops across it. And the op amp is going to do whatever it can do. It's going to do whatever it can do so that the voltage drop across this is equal to, right, because that's the voltage at pin 2, is equal to the voltage at pin 3. And the voltage at pin 3 is controlled by this potentiometer, trimmer, and the voltage coming in on P1-4. So it's a voltage that controls the current needed to get a voltage drop across these resistors. Yeah. And I want this guy to be the negative reference input. So it goes to ground. Yeah, we'll just connect it straight to ground. That's right. That's fine. Okay, so this guy goes to ground, but it's not supposed to be used for the power supply ground. That's right. Okay, got that. This here like this, and then this guy can go like that, right? That's fine. Move this guy down here. Yeah, save that. Yeah. And what does this top one look like? I just have it going like that. So we're gonna stay the similar. We're gonna stay the same. And how about to there? Yeah, kind of like that. Cool. All right. And we're gonna grab this. We're gonna move it. We'll snug it up a little bit. How about like that? That looks good. And I don't mind when the ground symbol is rotated. If you go to work somewhere, just ask the senior or chief or principal or whatever they call them these days, engineers, if they mind. If they mind, just rotate it whatever direction they want. I don't like that, personally. If I ever do it, it's because I'm in pain. Yeah. All right. This will be fine. So basically, P1-6 is if you want to measure a voltage, but you don't want noise over your ground cable, right, to get into your signal, then use P1-6. It's an input. It's not a power pin. It's an input. So it's the reference. It's the ref negative input, or the in negative, which it connects to ground, but since it's not the return path for the voltage source, like the V+, it shouldn't have noise on it yeah, you got it. All right, cool. All right, we got it, Nolan. We got it. All right, you got it. Should I snug this up a little bit? Can't hurt, right? Got 2 clicks out of it. Split the difference. Drop it down 1 more click. I could pull it back closer to this, but it doesn't really benefit me because I still won't be able to undo that. We're going to go ahead and place that op-amp drawing op-amp dual. Place this back here again, like that. That's right, I had to drag it down. I think I put myself on a 0.5 millimeter grid. I like to do my title blocks. I'm weird. I like to do my title blocks on a 0.5 millimeter grid, right? And then I like to do my schematics, like the symbols, on a 1/10 of an inch grid. So close enough. Actually, that's better than this guy. Let's go back to inch. 0.1. Nice. Yeah, so you could see my schematic is all on grid, always on grid. Schematics are always on grid. Your board can come off grid. No, never take your schematic off grid. Always stay on grid. And 0.1 inch, which is 100 mils, to me that's standard. That's the way it should be. I don't think IEEE 315 says, I don't remember. I've never had to been told to put my stuff on grid, so I don't remember if IEEE 315 talks about grid or not, but just stay on grid. If you see someone that's not on grid, tell them that Nolan told them that they should be on grid. Okay, all right. Yeah, only bad things can happen when you come off grid. It's never there's no good that can come of it from being off grid. Oh, but Nolan, I get to squeeze it in. No, that's not good. Right? It's not good. Okay, so I don't need to belabor the point that those are carefully drawn, and we'll match the capacitors that we have going on here. Yeah, and move that down and grab this, move that down. That's fine. We'll move the test point above the capacitor junction just because, shorten that one click. Okay. So clockwise is going to raise it, which is going to increase the voltage, which is going to increase the current. Clockwise here is going to lower this, which is going to lower the equivalent resistance of this, which is going to lower the equivalent resistance of this, which is going to increase the current so that it maintains the same voltage. So you have two ways to control the voltage here, R2 and R3. You probably want this guy to be the one that you calibrate, and then right? So that way, hey, 1 volt is 1 milliamp exactly. So this would be like your calibration. And then this would be your setting, right? Like, oh, set it to 1 milliamp. Oh, okay, dial it to 1 milliamp with that guy. You just leave this alone because this is what calibrates the ratio of the voltage and the current. And this is what sets the voltage. Yeah, there we go. This one adjusts the ratio, and this one adjusts the voltage. Okay. And that's the circuit, folks. That was pretty fast, right? Not too long. We'll drag all of this a little bit further to the right. Like that. Seems centered. Perfect. Okay. Save. And double check. Signal converter, dual op-amp circuit, single supply, THD, trimmers, plural. Yes, 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 yes. Save. Ground B+. This is really an optional. These guys right here are really optional. You don't have to use it. You're able to just populate it and use the voltage created by this. I should separate this with a resistor so that way it doesn't fight too hard. So that way this guy can actually do something, right? It's a weird place to put the resistor. Should I put it down here? Hmm. Move group, and there. Okay, we'll do that. Save. Perfect. Cap reference designators look good. Resistor reference designators, I may flip them around a little bit. This is an NPN. You could also do an NMOS. Maybe that's something I test. Like I solder up some with NMOSs and then some with NJFETs and some with NPN BJTs. I minimized the capacitance. Well, I didn't add capacitors here so that the signal doesn't have the lag of the capacitance, but the output right here that's driving the current has an RC filter, so it filters out the high frequency. So is that a good way to do it? Is that a good way to do it or a bad way to do it? I put the caps on the feedback or the output. Maybe I do it this way now, and then I'll do another one that has the caps down here somewhere, like right here. Maybe I do put caps down here. Because like a high frequency noise here is gonna get rolled off here, but the op amp here is gonna be doing some funny business. Spam caller. My microphone's still working? Yeah, looks good. Okay. Back to work. All right. We're gonna go with this. It's gonna be okay. And my gut was telling me to leave this without a lot of capacitance, but when I sit down to analyze it, I go, well, maybe I should put some. Yeah. Yeah. Okay. Well. All right. That is the circuit. Let's run. Let's rename it. Renumber the components. Boom. Oh, I have to set test points. Cancel. Hopefully that didn't break anything. This guy can go here. Doesn't really matter. This guy, we got one there, 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 here. Okay. And then I'm going to grab this. Oh. Grab this, move it. I think that was one click. And then grab this, and we'll move it back. One click. Two clicks. Two clicks. Two. 1, 2. All right. There we go. Should put a test point here, shouldn't I? Yes, sir, I should. All right. Let's see. Yes, sir, I should. Move group. How about that? A little crowded, but it should be fine. I could get another click out of this space right here. That right there. Move group. Move group. that the click? That's fine. Okay. All right. Yes. Yes, 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 yes. We have TP9 is on that guy. TP10 is down here on ground. All right. I like this. This is good. Renumber the test points, yeah. Boom. All right, cool. Save. Yep. For a moment there, I thought I misspelled initial, but it was just my eyesight. Okay, that looks good. I like this. Nice. Okay, script. Let's export schematic image. Overwrite. Yep. Wait a minute. Gotta double check. Oh, good. Okay, we have this set as the active project. Okay, now file, switch to board. These are the parts we need to fit in. This is the layout from the last board that we copied. Rip up group. Say none and show me T names. Boom. Delete group. This group. Delete group. Save. Move. Show all. Apply. Okay. Grab these guys. Drag them up so they're kind of next to it, not underneath of it, so I can place them a little easier. Okay, move over here so you guys can see what we're looking at. I should get used to that. Let me, I was thinking I should just draw like a thing here and then try and make sure I can always see it, like window fit, like that, bam. This probably doesn't need to be like that. I probably should move it like, well, that was it, right? More or less. It could be like this. Okay. This thing, when you pack it all in, you have to unpack it and go, well, what do I have here? Okay, let's look at this guy. R6, R7, R8. So we have, that's R5. R6, R7, R8. So R7, R8. And these right here, they go between ground and pin 2. Well, they're pretty close to pin 2 already. In fact, that guy still goes there. R6, where do I have R6? Is that this guy? Yeah, that's that guy. I could probably put R6 over here. Like this. You know, something like that. I wonder if I have it like this. That would be nicer if I did. Oh, thankfully, right? TP9, no. No, I guess it didn't. That's the positive, and that guy goes there. So this guy can rotate like this. Yeah. Okay. Like that. Then we'll drag this guy out of the way for now. Out of the way for now. We'll keep that guy next to it, sure. Unbreak, unsmash, whatever. Move this guy like this. Yes. Like that. Except they need to go to P1-7. That's what pin 2 goes to. So pin 2 will go down to P1-7. It's fine. I don't have any capacitance, and it's up here on the edge of the board. Might be more immune to noise if I rotate this a little bit, set it down here like this. That's the power, big power cap. You know, big power cap being relative, right? Grab this guy, rotate it, probably drag this down to like here. We'll figure it out. Grab these guys, we'll move them over a little bit, move group, and then probably put it like that. Now, that may be more sensitive, depending on people if people grab it. But anyways, this net right here is this guy. So, what do I name it? Just R6 pin 3. Good enough, right? Just out neg. Must be out positive. This is U1.1. This is Q1 dot base. This is out plus. Save. Yeah, so this net right here is that guy. That right there. This guy, boom, boom, boom. That's pin 2, right? Tight. You want that tight. Nice. And 7 is going to there as well. Can't help it, right? It has to go a little ways, but that's okay because like it's going to go all the way through the IDA and then all the way through your cable and then all the way, yeah. So that's really not that far. And let's see, so I don't remember where I have R2 going or R5 really. C5 is definitely power. We can leave it in the same spot for money for now. Oh, R5 is coming off our pin 1, going to the transistor Q1. Two caps, C8, C9. Now, there they are. Well, let's move y'all to the right side of the world. Okay, something like this. I don't know where C1 is, but you know, not supposed to be there. We can put this guy vertical. Kind of have a wasted space back there, don't I? Everything's going to squeeze in fairly easy, so I mean, I could put it like this. Q1, C5, and Q1. It doesn't have to be straight. I can angle it. Base. Now this guy, that collector. That C5 and C7. I don't really have a capacitor up there though. Kind of want one, all right. Kind of, yeah. Kind of want it to be bigger too, though. Copy, group, this guy, copy group. Move up to there. Grab one of these, put it there, sure. Name. Good enough, right? Not going to put 2 because I just want the large capacitance. C10. Move C10 up to here. The big capacitor. Something like that. Right click. What kind of, I don't have any. I do have a big one. There we go. Move this guy down to there. That reference designator needs to change. So, old. All right. Libraries here. Components, capacitor. This guy, well, not that guy. Cancel. Edit package. This guy, properties. We're in inch. I don't know what an inch is. We want it 1.5 millimeters. One point. 1.5, 12%. T names. Cool. Grab this guy. Oh, it was on that. Nice. Okay. Let's see here. Maybe I grab this and rotate it like this. Save. Hey, not open, save. Okay. Schematic. Board. Library. Update all. Good enough. Okay. Okay. Hmm. Yes, sir. That's not how you do it, Nolan. You have to look at what the circuit's doing. All right, so we got C10, Q1, TP9. TP9 can be down near the output, or it can be up here. We'll go ahead and put TP9 up here, right? Like that. Now this output has to go all the way down. That's fine. We'll manage. Like that. That's good enough. It's a good idea, but you know, let's train myself. Well, guys, I need to pause the video. I'll be right back. Is there a pause setting? Nope. Oh, pause. Yeah. Okay. We're back. Feel like a new man. Let's see here. Good stuff, good stuff, good stuff. And we want well, before I go too far, let me change this. Hey. Hey. Okay. Where was I? Just set that cap there. TP9. TP. Okay, and then and then that stuff doesn't need to be close to that because it comes down here to pin 5 and then pin 7 on that one. And maybe I should flip it and make 5 the high and 7 like that one and that one. Because then 7 would wrap around the world like that, and 5 would just kind of snake up like that. Well, we're going to have to regenerate the schematic image, but that's okay. All right, save. It's actually normal if you make a schematic change during the layout. That's normal. TP10 can go here. Beautiful. Should put even more in the middle of nowhere. Now we'll put it here. Cool. Okay, so our 5 is driven. Flip this around like that. That's better. Because that's the output, so it can go far. It'll be fine. There's the base of that guy. We got our caps there. Pull that 2 clicks the other way. Kind of center it a little bit more, you know. Put a little further, and then that gives the caps a little bit more room, just in case someone wants to use a larger cap. It'd be fine. They'll have plenty of room. Okay, something like that. That should be good. Now come down, hit the transistor, boom. The power comes through the transistor, right? That guy's power as well. Transistor output goes all the way down to pin 7. Excellent. This guy over here, what a mess, right? R2, R3, the pot, R1. Well, if R1 is anywhere. Yes, no, and R1 is somewhere. C1 right there. So that's C1. And then pot. Okay. Well, probably like this. Something like this. Something like that, maybe. Okay. R2. Right, we got R2. And C4 and C6. C4 and C6, yeah, they're up here somewhere, like that. And those guys are going to go to pin 5, right there. Beautiful. Beautiful. All right, grab that like this. TP4 is probably right there too. Something like, yeah, okay. Grab these guys, drag them out of the way a little bit for now. They'll be right back in there in a second. We'll grab these guys, move group here. Right click. What was R4 again? Oh, yeah. Between pin 2 and pin 3. Between pin 2 and pin 3. You know, in that case, it's probably not best to make that net so big, though. Here, this guy, 2 clicks up. This guy to there. This guy, you know how I tried to keep it away from the edge? Right back on the edge. I know, right? Some people just can't be helped. They're just helpless. That's why we have the word. Oh, 7 and 3. You know, if I didn't have the resistor between 7 and 3, should work. Should work, yep. Didn't need to drag that stuff down there, did I? R4 goes to the output. We can put R4 up there. That'll go there, and then that guy will fish down. Cool. Drag it up a little bit, right? We'll just leave it down for now. So this guy can go over the top. That will have to fish behind. I want to bring power up this side. I do have enough room here. It'll be right on the edge, but you know, it's okay. Can I drag those a little closer? This guy needs to go closer to this pin. Yeah, now we're talking. Take that guy a little closer and a little closer. Q1 can also move down a little bit. Now we got plenty of room for the power trace back there. TP9. Like that. Okay. Boom. Boom. This is feeling good. This is feeling good. Yeah. Yeah, it should be okay. You know what we could do? Drag that down. Give this whole thing a little bit more breathing room. Wow, we'll do them one at a time. Like that. Two clicks above. That. Let's center it. Good. All right. So I got C4, C6, 5, 4, 6. That's okay. One click. get away with that. Pin caps 2 and 3 are over on this side, like this. Not really. Gotta go like that. Yeah. Yeah, something like this. Don't want to cut the ground plane too much right next to it. All right, ground plane. Okay. Okay. You know, we can y'all watch the video and you're like, that right there, I wish he'd have left another 0.5 millimeter. Send me an email. Nolan, you needed to leave 0.5 millimeter between C5 and C4 on 08C005-A. Oh, okay. I'll add that to my list of things I can revise to improve, and you know, maybe I'll do that. Maybe I'll make a video and okay. Put this guy back here, right? Something like this. Okay. Something like that, maybe. Oof. I don't know. Maybe not. Nope, doesn't fit like that. Like this. Over one more click. Rat's nest. 2 clicks. We'll line them up. Okay, that's fine. Test point. Right on the edge. So snug this guy up a little bit. I have a test point over here too. Okay. Test point 5. It goes the other way. Test point 3. It's on the caps, so something like that. Okay. TP1 is on pin 4. We'll put TP7. I like to keep it down here, but I kind of crowded my cap. We're going to do this. We're going to put, for a change on this board, we'll put C5 and C7 over here. Oof. Huh. Yep, that's good. That's good. Something like that. TP1. Just kind of stagger it from the TP6 and 7. Or oh, dude, that's all the points. Huh. Okay, well, in that case. You know that space we put into the resistors? Watch this. Y'all were looking at your boards like, I don't see that space. Do you see that space? No. Man, that space would have been nice. Yeah, sure would. Tough. Tough luck, guys. Tough. Boom, boom. Boom, 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 boom. Pin 7, pin 5, TP1 and 2. Anything that looks too tight. All right, let's start routing. Bottom layer. Do I cut up this way? I think I cut up this way. Yeah. Okay. Ooh, feels good to see a nice big power supply cap, doesn't it? Sure does. Good feeling. Actually, no, that's fine. That's fine. And in fact, we'll drag this down. Nice. A little bit weird, but I want to bring it off the cap just because. Why not, you know? All right. Let's come down to here. Ooh, look at this. That's gonna look weird at that test point coming off. Eh, eh. Okay. Oh, that's crowded anyways. That's, all right, now let's try. Okay. Let's do that. Yeah. Sure. Hit that. Come up to here. Hit this. Go over to here. Hit this. Come up to here. Come on. Come on. Give it to me. It's like that Shakira song. Give it up to me. Good enough. And good enough. This guy. Oh, I had it just right there. Okay. How far away from that did I go? One more click. Like that. Looks a little excessive. Okay. Yeah, looks good. Nice. Okay. Grab this guy. Pop it in. Pop it in. Over. Up. Grab this guy. Oh. Oh, man. All right. Let's take it up like this. Over, out, and then like that. Nice. Okay. What are my other options? That's an option. Or I should send to the, now let's do it like this. Let's rip this up right here. Bam, bam. We'll grab this guy. We'll send it to @cap. Yeah. That way it's not hanging off there in the middle of nowhere. All right, we're almost there. This guy can go down to there, to there. Yes, no. Like that. This guy can come down to there, and then the output, we can fish it right down through here. Oh man, this is so nice. So well, let me rat's nest it, make sure I'm not violating anything. So nice, so nice. All right, now, since we have the luxury of choosing, we go through here, right? Or do we go underneath the cap? We're going to go underneath the cap because the cap stitches the top and the bottom. Hang on a second. Escape, rat's nest, rip up a little bit of this right here. Like that, rip up this and this. Now rip that up to move this stuff right here. Move group, and we'll set this cap there, and this one will stretch out a little bit. Yeah. And can I move the group again? Move it one click closer to the, oh, damn. Maybe that was two. It's okay. Now we'll connect them. We'll just take it straight down. And then over. And down. There we go. Okay. I think that's fully routed. Save. Well, save. Let's look for the unrouted layer. Apply. Okay. Yep. Fully routed. Nice. All apply. Okay. Save. And should I go bump, 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 bump? No, this goes straight. You're fine. That angle's okay. It's the return. It's the return of the. Oh wait. He didn't just say what I think he did he? It's a little too awkward for me. We're gonna do it similar, but a little different. Yeah, basically. Basically as it was, right, on that one. That's an acute angle. Most people don't like that. It's okay though. We're going to leave it. No. I don't like going to a finer grid, but we're not, we'll go to 0.1. We're not placing parts, we're just routing the traces. Yeah, so the current will leave on pin 7 and return on pin 5. To ground. Good enough. Good enough. Save, and wow, guys, I think we're done. I think, well, I mean, not really. I mean, the party's just starting, but here, let's, all right, brain on, please. Cancel. Need to, well, no, that's the right spot, but wrong folder. miniPCB. It's a script, that's why. Okay. Okay. Nice. Save. Save. Because I like it so much, I'm going to double click it. Export part image. Yep. Yep. Perfect. Beautiful. Let's go back to the schematic. And let's export the image again. Cool. Okay. Save. All right. Close. Close. Go back to the project. Go down to the project. Say new. Board. Save. 08 Charlie -005. Wow. Dash A. Oh my God. A. Charlie dash, and it's an X. So, okay, and then we will panelize it. Yeah. All right. Sorry, my brain is shutting down for some reason. Here, here, here. Perfect. All right. Now let's set the image frame. miniPCB panel image frame. Yep. Save. Okay. Now that we've got this, let's export the images, and then we'll do the Gerber's script. miniPCB. Export Gerber images. Yep. Yep. Okay, save. Now let's export the Gerber files. Woo-hoo-hoo-hoo. Nice. I trust my job. Meanwhile, back at the ranch. So we have a voltage to current. Naturally, what comes next? Current to voltage. So we'll do a current to voltage. After the current to voltage, we could do the discrete analog to digital converter. We could do a voltage to frequency, frequency to voltage. We'll basically have had 3 signal converter boards. Capacitance to voltage, which basically would be like a frequency that varies with capacitance, and then, well, one way to do it would be a frequency that varies with capacitance, and then a frequency to voltage converter. Is there a direct capacitance to voltage circuit? It would just be a capacitor divider, wouldn't it? Well, with an op amp, yeah. Sounds interesting. Okay, file, open, job, Exelon, process job. Okay, close that, save. Okay, let's zip those Gerber files. Signal converters, Charlie, here. Date modified, DRD down to here, compress. Delete. I already deleted the other stuff. Okay, cool. We're ready to generate the data sheet and then update the engineering change order. So documents, custom office, miniPCB, data sheet. This is a voltage to current. I didn't go in there and do it yet. It's fine. Yikes. All right, so properties. I have to remember how I did it. What was it? Signal converters, 08 Charlie, like that. No, it's just, yeah. Well, okay. Group name, signal converters, modify, take off the C. Okay, there, because it's group 08. Yeah. Circuit name. Variant description, single supply, dual op amp, THD, calibration trimmer, and set bias trimmer, set trimmer, signal trimmer, signal trimmer, signal trimmer, board design, PCB 50-A-07. Yeah. 08 Charlie dash 005. 4 pieces per panel. Engineering change order 1007. Part identifying number 08 Charlie dash 005 dash A, because we decided probably a long time ago, right, to put the revision letter up in the thing so it's on every sheet. And I'll zoom out so you guys get to enjoy this. There we go. That's enough. Developer, macros, run. Save the document. Save. I know myself way too well, don't I? Choose a location, except it's not the more locations. Browse. Just pull up this right away, guys. Why? Why'd y'all have to go and make me do all this? Okay, now run the macro. Run. It's inserting all the images we exported from CAD. Cool. And the rest of it is just kind of template stuff that's just kind of to get started. When we have the boards made and we solder them up and we test them, and then we spend an hour or two on each data sheet to get it perfect, we'll completely rework it. Wishful thinking, Nolan. An hour or two. It's going to be 4 hours per data sheet. 5, 6. It's going to be a day. A day per data sheet. Yeah. Go up to this guy. Mirror. Oh, select it. That helps. Yeah. Now flip horizontally. Cool. Nice. Cool. Look at that, guys. Look at that. Top copper. So clean. So clean. No cuts. Nice, right? It's just nice. Oh, that's good too, how it didn't try and, I got it close enough on the top where it didn't push it around the side. Well, I guess it was close enough on the side too, but yeah. That's just nice. Power comes in, boom, 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 comes back here to this humongous cap. And then over there. Yeah. Okay. Okay. That's good enough for today. Nice. I like it. Close. Let's see. 08 Charlie. Don't have one. Did I accidentally type this over here? I did. Well, I did. So we are going to duplicate this sheet, move or copy. Put it in front of 09, create a copy, say OK. Come back here, say rename, Charlie. 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 Current to voltage. Sorry, what? Voltage to, no, current to voltage has its own. Yeah, it's okay. We'll duplicate this guy again. Move or copy. 09, create a copy. Here, rename Delta. And, current to voltage. Do a lot of band buttons from bot, something like that. It's an idea. We'll go back to, y'all can't see it, but it's a tab called Overview. We'll hit Update and runs through them all, does its math. Save. Okay. We need to update our design standard to include the new board that we made, the 50 by 100. We need to update the template to have a correct drop-down menu. And there's stuff we could do with like just writing VBA code to harvest data from our data sheet, put it in a spreadsheet, which basically is like the product catalog, but I might make this one the product planning catalog, and then the product catalog, like the actual one, I might make it where it's per the data sheets. So if I don't have a data sheet, it's not in the catalog. I like that. It's not in the data sheet, it's not in the catalog. Plus it'll make it so clean. Just like, okay, we can close this guy, go back to Eagle. I did delete them. Okay, cool. Nice, 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 nice. Wow, that was fun. Well, let's see. Anything else we need to talk about before I get off the phone? Well, we made good progress. That was less than 2.5 hours. And, well, restroom break, so probably more like 2 hours. We designed the circuit, captured the schematic, did the board layout, all that. Generated Gerbers. We're ready to order it. And we'll order it, today's Wednesday, so probably tomorrow. Tomorrow my engineering buddies want to get together after work, so probably may or may not do a video tomorrow. So maybe I should squeeze in another mini PCB tonight so that I have enough to order. because I only have 3. I should probably order 5, not 3. But if I order 4, then if I order 4 twice a week, then I stay on track for my my goal, my crazy goal, which I kind of decided not to do, like 8 a week. Ugh, that's for the rest of the year. Okay, that's a lot of work. Wow. Anyways, yeah. All right. Well, thanks, guys. I'm gonna hang up and figure out what to do next. Thanks for hanging out. We'll talk to y'all later. Bye.